Today we're going to talk about logarithmic graphs. We have spent some time with the properties of logarithms and just kind of playing around with logarithms with our calculators and things like that. So now I'm going to show you how to graph them. So this is the basic parent function, f of x equals to log base b of some number x. The first thing you need to make sure you understand that a logarithm is an inverse of an exponential function. So if you go to Desmos and you were to actually type y equals, because remember f of x is the same as y equals log base b of x, you will see a graph that looks like this. Of course, the one on Desmos will be prettier than this one. If you graph this exponential, you of course would want to type in y equals 10 to the x power, and you will see a graph that looks similar to this. Okay? So that's the difference between a logarithm and an exponential graph. They still look like a similar curve, but they do go in different directions. So in order to graph logarithms, what we're going to do is first we're going to rewrite it in its exponential form. And we did that the very first day we talked about logarithms. Write in exponential form. So we're going to rewrite this as y equals 2 log base 2 of x. We're going to grab our base, go to our exponent, and set it equal to x. Now, that looks very, very similar to what an exponential equation looks like. But a true exponential equation has x as its exponent. So notice in a true exponential, notice that the x and the y have switched places. Now, y is my exponent and x is my number, as opposed to the true exponentials that we did on the first day always had x as their exponent. So the x and the y actually switch places, and that's what makes these problems inverse. So what we're going to do a very, very similar table to what we did with the exponentials. We're going to use my favorite three numbers, -1, 0, and 1. And notice where I put them this time. Since y is the exponent, I'm going to fill my favorite numbers in the y column and then turn around and match those up with the x that goes with it. So we know 2 to the -1 ends up being 0.5 or 1/2. Anything to the 0 power is a 1. And then, of course, we know 2 to the first power is a 2. So, although my numbers are reversed from what we did the other day, they're supposed to be reversed, because when I rewrite a logarithm as an exponential form, or in its exponential form, I should have y as my exponent and not my x. So now what I'm going to do is I'm going to plot these points. So I'm going to go over to, make this a little bit bigger so it'd be a little bit easier to see. I'm going to go over to 1/2. I'm going to go over 1/2, and I'm going to go down to -1. Then I have 1, 0, and I'm going to go over 2 and up 1. So your graph is going to kind of grow, and then all of a sudden it's going to turn. Okay? Now, as far as answering these questions over here, I have a domain value, which is all numbers x greater than 0, because I did not graph any numbers on the negative side of x. I only used the positive side of the x-axis. Your range is all real numbers. Okay? As x approaches positive infinity, your y values approach infinity. So that would be this infinity arrow. As x approaches 0, your y values approach negative infinity. That would be this infinity arrow. It's going to get really, really closer to 0, but it's not ever going to reach it. So the x-intercept in this problem is 1, 0, and the asymptote is x equals to 0. So this number and this number, whatever number you put as your domain and your asymptote should always match. So what that means is there is an understood line right here that your graph cannot cross. Okay? Your graph cannot cross that asymptote line. So let's talk about the next one. All right. I first need to rewrite this as y equals to log of 1/3 to the x power. Then I'm going to take my base, 1/3, raise it to the y power, and set it equal to x. So I'm rewriting this in exponential form. Notice that when I did that, y is my exponent, and that's what you want it to be. So we're going to put my favorite three numbers in the y value and figure out what the x values are that are associated with it. So 1/3 to the -1 is equal to 3. Anything to the 0 power is equal to 1. And 1/3 to the first power stays 1/3. Okay, so I am going to graph these points. That would be the point 3, -1. That would be the point 1, 0. And that would be the point 1/3 and 1. Now notice this time I'm closing in on the x or the y axis, but I'm going up this time instead of, or I'm going down this time instead of up like the first one. The reason that is because my base is between, can't be equal to, I apologize. It is between 0 and 1. Up here in the first example, our base was bigger than 1. So that's why the graph went this way. And when your base is smaller than 1, it goes this way. But notice we still have not crossed that y-axis yet. Oops, not what I wanted to do. I have not crossed the y-axis. All right, so when we answer our questions, we are still all numbers greater than 0 for the domain. Our range is -infinity to +infinity. As x approaches infinity, y approaches infinity. As x approaches 0, because we're talking about this arrow, so that arrow is getting closer to that 0 line. As x approaches infinity, your y values are going down. So we're talking about this infinity arrow. Now, my x-intercept is still 1, 0. My asymptote is still x equals to 0. X equals to 0 is your y-axis. So this is a little bit different than graphing the exponentials. Kind of similar, but just a little bit different. Okay, so let's talk about graphing problems that look like 3 and 4 and 5. We'll even do number 6. It's down there somewhere. Okay, so here I have y equals log 4 of x minus 1. So I'm going to raise 4 to the y power equals to x minus 1, put it in its exponential form. Then I'm going to add 1 to both sides to get x by itself. So this is what I'm graphing. Now, what I'm going to do is I'm going to start with my favorite three numbers. And that would be -1, 0, and 1. And I'm going to plug that into this equation for y and figure out what the related x is. So 4 to the -1 power plus 1 equals to 1/4 plus 1, which is 1 1/4. 4 to the 0 power plus 1. Anything to the 0 power is 1. So 1 plus 1 is 2. And then I have 4 to the first power plus 1, which is just 4 plus 1, which is 5. So I'm going to graph plot all these points. Okay, and so what happens here is when I have, well, let's plot the points first and then I'll tell you what happens. So I'm going to go over 1 1/4 and down to -1. I'm going to go over 2, 0, and then I'm going to go out to 5 and go up 1. So my graph looks like this. Now, things change when you shift to the left or the right. All right, so your domain will change. Whatever the movement is, it changes. So we are moving one place to the right. So my domain are all numbers bigger than 1. My range is still all real numbers. Positive infinity would be this arrow. So as x approaches infinity, so does the y value. As x approaches 1, because this time we have moved our domain over. Our x-intercept we can get out of our table, which is 2, 0. And then the asymptote also changes. Remember, the domain and the asymptote have to stay together. So that would be x equals to 1. Now, what makes the domain and the asymptote change is if you have a left or right movement. So if you have y equals to log base b of x plus c, that's going to move you to the right. So your domain would be x is greater than -c, and your asymptote would be x equals -c, because that moves you to the left. If you have y equals to log base b of x minus c, that's going to move you to the right. So your domain would be x is greater than your c value, and your asymptote would be x equals to whatever your c value is. Just like any other movement, when you go inside a function, it's going to move you either left or right. And remember, it moves the opposite of what you see. So when I see that plus sign, I know I'm going to move left. When I see that minus sign, I know I'm going to move right. Now, in the fourth example, since if this were in parentheses, we would move 2 places to the right. But since we are not in parentheses, this is going to drop me down 2 places. So if you have y equals to log base b of x plus c, it moves you up c units, and none of this changes except the x-intercept will change. And if you have y equals to log base b of x minus c, that's going to drop you down c units, and that will still affect your intercept. Your domain will still be bigger than 0. Your range will still be all real numbers. We'll have to look at this according to the base number that we have. My x-intercept is going to change, and I can calculate that in my table. And my asymptote is going to stay at 0. So it's going to stay at the y-axis. So I'm drawing in my asymptote right now. before I make my table, I'm going to have to rewrite this as an exponential problem. So the first thing, y equals to log base 3 of x minus 2. Now, since this minus 2 is not in a parentheses like this minus 1 was in example 3, what we're going to have to do is we're going to have to add that first to get the logarithm by itself. So I get y plus 2 equals to log base 3 of x. And then I'm going to now rewrite this, grab your base, raise it to that power. So 3 to the y plus 2 power equals to x. Now, I'm still going to make my table. And I am going to put my favorite three numbers, -1, 0, and 1 in my table. When I plug in -1, so I get 3 to the -1 plus 2 power. Which gives me 3 to the first power, which is 3. Then I get 3 to the 0 plus 2 power, which is 3 squared, and that is 9. And then I get 3 to the 1 plus 2 power, which is 3 to the third, which is 27. Now, obviously my graph does not go up to 27, so I am going to plot those points. I'm going to go over to 3 and down to 1. Then I'm going to go over 9, 0, so that's 3, 4, 5, 6, 7, 8, 9. And then, of course, I would have to go all the way out to 27 and up to 1. So my graph is going to come and go this way. Okay, so be very, very careful with your graphs. Now, as x approaches infinity, so does y. And as x approaches 0, which is the red line, y is going down. So that's why it approaches negative infinity. Now, my x-intercept is wherever 0 is in my table. So I ended up with the x-intercept 9, 0. 2 more problems. And if you notice, they have a couple of movements going on. This number tells me to go to the left, not right, I'm sorry. That number tells me go to the left 9, and this number tells me to go up 4 places. Now remember the up 4, I'm sorry, not the up 4, apologize. This movement changes your domain, your x-intercept, and your asymptote. So my domain is all numbers greater than -9 because we're moving to the left. That means my asymptote is at -9. So I'm going to come over 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to put my asymptote there. And everything I do, I'm going to graph to the right of that line. Okay? Now, I have to rewrite it before I can plug in my numbers. So I'm going to start with y equals to log of 1/2 x plus 9 plus 4. So the first thing I'm going to do is I'm going to subtract 4. So I get y minus 4 equals to log of 1/2 times x plus 9. Always move that up-down movement, and then once you do that, you can rewrite in exponential form. So that would be 1/2 to the 4 minus y power equals to x plus 9, and then we're going to subtract that 9. So that will be 1/2 to the y minus 4 power minus 9 equals to x. Now I'm going to make a table, but this time I'm going to change my table just a little bit because -1, 0, and 1 is not going to give me a good picture of what this graph is supposed to look like. So what I'm going to do is I'm going to build my table around my exponent. So I'm going to take my exponent, y minus 4. I'm going to set it to 0. And I am going to build my table around y minus 4. So I'm going to do 3, 4, and 5. So I'm going to plug 3 into this equation. So that would be 1/2. I said 1/2, got ahead of myself. That will be 1/2 to the 3 minus 4 power minus 9, which gives me 1/2 to the -1 power. 1/2 to the -1 power is 2, and 2 minus 9 is -7. And I apologize, I put my numbers in the wrong spot. Our exponent is a y, so we should put our 3, 4, and 5 on this side. So my -7 goes in for x. Now I'm going to do the same thing with 4. That gives me 1/2 to the 4 minus 4 power minus 9, which gives me 1/2 to the 0 power minus 9, and 1/2 to the 0 power is 1, and 1 minus 9 is -8. So last number I'm going to plug in is 5. So I have 1/2 to the 5 minus 4 power minus 9. That equals to 1/2 to the first power minus 9, and that gives me -8.5. Okay, so I'm going to plot these 3 points. I'm going to go over to -7 and up to 3. I'm going to go over to -8 and up to 4. Then I'm going to go over to -8.5 and up to 5. So my graph is going to get really close to that vertical line asymptote, but it's not going to cross it. So this would be what your final graph would look like. Now, the only problem is I don't have my y or my x-intercept. So what I'm going to have to do is I'm going to have to do one more point. You will definitely need your calculator for this one. That would be 0 minus 4 minus 9. So I have 1/2 to the -4 power minus 9. So 1/2 to the -4 power, that becomes 2 to the +4 power. That is 16 minus 9, which is 7. Put 0 here, I put it in the wrong spot. We're plugging that in for y. So I'm going to pull this graph 1, 2, 3, 4, 5, 6, 7. That graph is going to kind of continue on through that point. So I now have my x-intercept at 7, 0. Now, as y approaches positive infinity, that's this arrow, as y approaches positive infinity, my x is approaching 9, or -9. It's approaching that line. As y approaches negative infinity, this arrow is approaching infinity. So if you have any questions about the graphing, please make sure you contact me. All right, so the last problem, we have 2 movements again. We're going to move to the right 2 and up 1. This movement changes my domain. So I'm going to shift my domain to all numbers greater than 2, which means my asymptote is also going to shift. If you move a logarithm left or right, the asymptote shifts left or right with it. My range is still all real numbers, and we'll calculate the rest of these once we see the graph. Now, I have to rewrite it before I can make my table, so I'm going to rewrite this as y equals to log base 5 of x minus 2 plus 1. I'm going to subtract my 1 first, so that's y minus 1 equals to log base 5 of x minus 2. I'm going to write this problem in exponential form, so 5 to the y minus 1 power equals to x minus 2. And then I'm going to add 2 to both sides, which gives me 5 to the y minus 1 power plus 2 equals to x. So now I am not going to use my favorite numbers because I have x or y minus 1 as my exponent. So I'm going to take my exponent, set it equal to 0. So I'm going to build my y table around 1. So I'm going to do 0, 1, and 2. So I'm going to plug that into this bottom equation here. So 5 to the 0 minus 1 plus 2 gives me 5 to the negative 1 power plus 2, which is 1/5 plus 2, which gives me 2 1/5. That also gives me my x-intercept. So my x-intercept is at 2 1/5, 0. I'm going to plug in 1. So 5 to the 1 minus 1 power plus 2. That gives me 5 to the 0 power plus 2. And that gives me 1 plus 2, which is 3. And then I'm going to plug in 2. So 5 to the 2 minus 1 power plus 2 equals to 5 to the first power plus 2, which is 7. Now, since my asymptote, I've already drawn that in, all of these points should be to the right of that asymptote. So I go over 2 1/5, so roughly about here, a little bit past that line, and stay at 0. I go over 3 and up 1, and then I go out 7. That would be 4, 5, 6, 7, and up 2. So I start really close to that asymptote, don't cross it, and then I curve away from that asymptote. All right. If you have any questions about graphing logarithmic functions, do not hesitate to contact me.